Assalamualaikum, madam. We are from SAJA Boys, and for OSHA group presentation, we have chosen our topic, which is higher analysis of the KLID power station explosion, Australia 2035. First of all, I'm gonna introduce our team members, which is Ahmad Aiman Hakim bin Muhammad Arif, Ahmad Fitri bin Ammar, Muhammad Halid bin HASAN. Next, I will introduce our slide topic. Risk assessment is a fundamental component of industrial safety management. It allows organizations to systematically identify potential hazards, evaluate the likelihood and severity of risk, and implement appropriate control measures. One widely adopted method is the HIREC framework: hazard identification, risk assessment, and risk control. This structured approach ensures that risks are not only recognized but also effectively managed to prevent future incidents. The objective of this study is to apply to the HIREC method to the KLID power station explosion in Australia, which occurred in April 2025. This case highlights the importance of safety culture, maintenance practice, and organizational governance in high risk energy industries. So I will give a bit of incident description at Australia. For 2025, a significant industry incident occurred at the Kelite C coal-fired power station in Queensland, Australia. A furnace explosion triggered by clinker build-up inside the boiler unit caused major damage to the facility and disrupted electricity supply across the region. Although no fatalities were reported, the incident led to severe equipment damage estimated at over 5.4 million US dollar and raised serious concern about the station safety practice. Investigation revealed that staffing shortage, poor maintenance schedule, and a weak safety governance system contributed significantly to the incident. Clinker build-up, a non-issue in coal-fired plants, were inadequately monitored and controlled, allowing the conditions to deteriorate until an explosion occurred. The incident also underscored the importance of adequate preventive maintenance, worker training, and organizational commitment to safety culture.
Thanks to Fitri. We will continue to the hierarchy table. Uh, we have we have formed three process or activities that can causes hazard. The first one is the boiler and furnace operations. Hazard is the clinker build up, ash deposits. Possible consequences is furnace explosion, equipment failures, and the existing controls is the manual monitoring and periodic checks. The likelihood is 4 and the severity is 4 major. The risk level is high. Additional controls is automated clinker detection and increased inspection frequency. The person in charge is plant manager. The target date is immediately. The second one is the boiler pressure management. High pressure steam, the hazard is high pressure steam release. The possible consequence is boiler blast, fire, and worker injury. Existing control is gauge and relief valve. The likelihood is 3 and the severity is 4. The risk level is high. Additional control is the real-time sensor and predictive maintenance program. The person in charge is the engineering department. The target date is 1 to 3 months. The last one is the power distribution. The hazard is come from system overload and sudden outage. The possible consequences is the regional blackout and disruption. The existing control is the backup system and SOP. The likelihood to happen is 4 and the severity is 3. The risk level is medium. The additional control that can be applied is stronger redundancy and faster load balancing. The person in charge is the operation manager. The target date is 3 to 6 months. Next, we can see that we have find that there are 4 things. The first one is the clinker build-up hazard was recognized but not adequately mitigated through engineering control. The second one is the preventive maintenance. Schedule were insufficient, increasing the likelihood of equipment failure. Staff shortage and worker fatigue were major human factor risks that compromise the operational safety. The last one is safety governance was weak, with audits failing to enforce corrective actions. Next, I will give to my friend Ahmad.
Here are some recommendations to stop something like the findings from happening again. First, the clinker problem. The workers were probably relying on manual checks, which is slow and not always reliable. That's why we suggest installing an automated clinker monitoring and removal system. With an automation, the risk is spotted early and the buildup can be cleared before it becomes dangerous. Maintenance is another big one. The current system was more reactive, fixing things only after they are failed. But by then, it's often too late. We recommend predictive maintenance using digital monitoring tools. This kind of system can see problems coming before humans can, so repairs can be made in time. Next, we need to talk about the people working at the plant. Many of them were doing overtime, sometimes too much, and fatigue set in. When people are tired, mistakes happen. That's human nature. So, one of our key recommendations is to hire more staff and make sure working hours are regulated. This way, workers are alerted and the plant runs more safely. And lastly, the workers' protection. The PPE and ventilation they had were probably basics, not really designed for the heat, fumes, and fire risk in this environment. Upgrading the PPE to heat-resistant suits and improving ventilation would make a huge difference for worker safety and health. And now, for a conclusion, the Kalite power station explosion serves as a critical reminder of how organizational and technical failures can converge to create significant industrial incidents. Despite being preventable, the incident occurred due to ignored warning signs, poor safety culture, and inadequate maintenance practices. By applying the hierarchy method, it is possible to systematically address these issues and implement controls that not only reduce risk but also foster a stronger culture of safety in the energy sector. Ultimately, this case underscores the importance of proactive risk assessment, continuous monitoring, and robust governance in preventing catastrophic failure in high-risk industries. That's all coming from us. Thank you very much.